Hello, everyone. Thank you for joining this seminar series organized by the Empathic Computing Laboratory. I'm your host, Aladdin, and our guest speaker for today is Suen Pai, who is currently a project senior assistant professor at Keio University, Graduate School of Media Design. His research interest is in augmented, virtual, mixed reality, human-computer interaction, and physiological sensing, human factors. He worked on many impactful projects, including Airbus, Google ATAB, and won a lot of awards for his research. The title of the talk is Leveraging Perceived Reality for Cognition, Assistance, and Augmentation. And the talk will be roughly an hour, followed by brief questions and answer. Please join me to welcome Professor Pai. Thank you for joining us today.
Yeah, thanks, Aladdin, for the introduction. Gotta say, it feels very surreal to be on the other side of the desk. So for those of you who don't know, not only was I an ECL member in the past, from 2019 to 2021, but I was also the one who sort of started this seminar series. So maybe if you look back to the first few talks, you'll find that it was me doing what Aladdin is doing with the exact same setup, the microphone and the headphones. So yeah, fun times. It's great to be able to share my work this time. So let me go ahead and share my screen. I think that should be fine. All right. So I realized that when I joined ECL in 2019, I never actually had a chance to introduce my work and what I do. I just got right into what I was doing. So I suppose this is a good opportunity to also let some of you who have worked with me in the past to know what actually I've been doing before joining ECL and also what I'm doing right now. So please sit back, relax, and enjoy. Grab some drinks, grab some snacks. I've got my MapD Sprite over here. And let's begin. So the title of my talk today is Leveraging Perceived Reality for Cognition, Assistance, and Augmentation. And if you are interested in anything that I am discussing right now, feel free to interrupt. I have the chat window open. If there's if any of you want to say anything, just feel free to type into chat and I'll do my best to reply to you in real time. So my talk today is a little bit more about actually my journey as a researcher from sort of during the end of my master's all the way until now and how my research topic evolves. And also I'll be sharing a lot of different kinds of research and none of them in detail. So if you want to know more about it, feel free to ask more questions, or if I do not recall the small details, I will also be sure to provide you some information on where you can find such papers online. All of them are basically published online. So yeah, they're all available for you to have a look. All right. Right, so who am I exactly? I'm actually a Malaysian, and I did my undergraduate and master's degree at the University of Malaya in Malaysia, which is, I believe, the oldest public university in Malaysia. So that's from 2009 to 2015. My background at that time was actually engineering, mechanical and manufacturing engineering. However, at the end of my undergraduate, I find myself to be more interested not so much in the manufacturing processes, but actually closer to like AR, VR applications. It was probably fueled from like gaming habits in the past. But then to me at that time, you know, or to a lot of people at the time, it was still very much like a gaming application, a gaming use AR, VR stuff. I think that time one of the well-known users was simple AR games on the Nintendo DS. So I was sort of interested in that, but I do not know of any researchers or professors who was working on such a topic in the engineering department, except for one. So I had one professor, his name was Yap Hua Jen. He was my advisor during my undergraduate thesis as well as my master's thesis. And his main research was actually on the use of AR, VR to simulate machining processes. I thought, you know, that's perfect. It bridges with what I'm currently doing and what I'm interested to do. So I did a little of that during my undergraduate and master's research, specifically the use of AR to simulate machining and manufacturing processes like CNC machining and robotic arms. However, after doing that, I realized that my interest really lies in this AR, VR direction. And so I looked for a PhD specifically in this topic, and that brought me to Keio Media Design, Graduate School of Media Design in Keio University in Japan, which is where I am now actually. So I did my PhD there from 2015 to 2018 for 3 years, exploring. Well, I'll talk a bit more details on what I explored during my PhD afterwards. But it's basically more about interactions of within the VR space and how it can be used for us to redefine human motion. And then shortly after, by 2019, I applied to be a postdoc researcher in ECL. So I was there from 2019 to 2021. And sort of here is an exploration of empathic computing in the realms of XR technology. And then by mid 2021, I moved back to KMD because I got offered a faculty position. So right now I am actually what's called a senior assistant professor, which I suppose is not a very common title in most other schools and departments, but essentially what it is like a bit more experienced assistant professor, somewhere around the lines of like, I guess, senior lecturer around there. So this is sort of my team at Embodied Media. This is actually a slightly larger team than this. This is just taken during a recent Christmas party. Actually, maybe it's a 2021 Christmas party. It's not the most updated, but there you go. Just a quick look at my team. It's quite an international and diverse team. You may wonder if I teach or do research or work together in Japanese language. So actually not so much, because the lab is a lot of international students for me to work with. Okay, so I mentioned a little bit about what I used to do on the manufacturing side, AR, VR in manufacturing, and how I moved slowly to more focus on XR, and then empathic computing, and then sort of in general HCI direction. So I will sort of detail this journey overall, and I present different projects which you may or may not find interesting, and we can hopefully trigger some discussions and also hopefully inspire your own personal research direction. One of the key things that I do actually want to mention regarding a lot of my research is that I always try to maintain close collaboration with industry. And I think that's actually a very important thing if you want to ensure that your work or what you're proposing to do sort of has a good social impact, and also doesn't just stay within the realm of this research bubble. So it's nice to always be able to collaborate. And that's something that I've been doing since I believe since the end of my undergrad, actually. So one of the earliest collaboration was Airbus. Airbus was one of the earliest collaboration during the end of undergrad and master's research. And then afterwards, the next was like Fujitsu during my first year of PhD research, followed by NTT research. So NTT is, you may know Fujitsu, I suppose, but NTT is a very famous telecommunication company in Japan. I guess something like Skinny, but it's bigger than that in Japan. So work on that during my PhD, and then afterwards during my postdoc, work with a bunch of other companies as well. Most notably, Ignition Point is actually a consulting company in Japan, technology consulting company in Japan. Cicero is from Australia, a research company. Google ATAB is, well, Google. These are people that I collaborated with, industries that I collaborated with when I was during my time in ECL. Jeans Meme is something sort of in between during my PhD and postdoc. Also collaborated with them. They are actually a very famous eyewear company in Japan. And then right now, as a faculty member in Keio, I've been working with Mediva, which is a medical consulting company, very big medical consulting company in Japan for some research, assistive design research. So this is just for me to bring forward the fact that I think it's very important for most of your research to find some way to collaborate with companies. Also, in a more practical sense, it provides hopefully some additional funding for you to fund your research direction. And also, it could open windows for future job opportunities as well. So I think it's just generally a win-win situation if you can secure collaboration with companies. The way how I like to structure my research interest is this sort of T-shaped model. I'm not sure if you guys have heard of it before, but basically it's like one main pillar of research interest, followed by other additional directions, which you sort of branch out. So you don't just focus on your main pillar, you also try to marry different research fields. And for me, my main research field is obviously XR, which covers AR, VR, MR. But at the same time, I'm mainly also looking at things like human perception, human physiology, human augmentation, and also inclusive design. So this is something that I also highly recommend for a lot of maybe early researchers, you to think of what your main pillar of research is, and then how you can potentially explore different aspects and how you can combine them to create a novel research direction or a novel research idea for your work. Okay, so a little bit back to my early research from 2012 to about 2014. It's generally about a time when there was not very good commercial AR VR devices. Sort of very early the time for, I guess, the first Oculus. I don't recall exactly when. I think that was like by 2013, 2014, the first like DK1, DK2. And for that, I was mostly exploring the engineering applications of the technology. So maybe I just share a little bit of that first. So these are actually works in terms of the AR application for manufacturing. The one on the left is actually how we can use AR to simulate a robotic work cell, how we can model inverse kinematics of the robot arm so that we can program the robot to pick and place objects on a conveyor belt, place it on the pallet, all without having to use physical materials. And the right one is actually a full CNC machining simulator. Now, looking at this, it feels like the quality is very bad because this is sort of pre-Unity. This was actually built with AR Toolkit. So I suppose some of the newer researchers in AR VR, they don't need to worry about using AR Toolkit anymore. But back then, it was one of the great platforms for developing AR applications. However, it doesn't really come with nice user interfaces like Unity does. You know, if you want to have a cube, you don't just press insert cube and you get a cube. You have to draw the edges, draw the vertices, and so on and so forth. So it's never it's not an easy process. It's with using with OpenGL. Actually, Mark may know a lot about this because he is one of the co-founders of AR Toolkit, I believe. So that was in the past. And I worked on that a little bit during my undergraduate and master's research. Then moving on a little bit to my accessing to be my PhD direction with the emergence of reliable VR HMDs. At that time, I was still very new to the whole direction as well. So I was just sort of thinking, how do we imagine novel input and interactions developed within this AR VR space? And one of the initial things that I quickly found out is just how do you actually move around in VR, right? If you want to travel far, how do you do that? And also, what is the best way, the labeled best way that you can interact with different objects? So these are just very basic questions initially that I was just trying to answer as I explored some of these new, more commercially available VR devices. And it's something that's also actively being looked on by a lot of researchers and also a lot of companies at the time. I suppose, Oculus is obviously looking into that a lot. So one of the first research that I published on this is actually how do you move around in VR with a balance between what you feel is natural versus how much space that you actually take in a virtual space. So I believe this is actually one of the first works that look into the idea of moving around with your arms, just with your arm swinging, as though you are walking, but just the arm swinging part. So this is one of the first works. There was another work, I believe, but that was requires you to press the buttons on the controller. Whereas for this is pure gesture based on a certain sort of logic that I developed for it. So it's a very simple idea, but the idea is that you're able to your body's direction is independent from your head direction, as it's like real life. You're not just moving where you're looking. You're able to face a direction. You just swing your arms as normal. So right now I'm just using controllers, but it can be any kind of hand tracking devices, and you're following you're moving to a specific direction based on where your body is facing. And then I published some works on this. So this is just published in MUM 2017. MUM is not really like the biggest impact conference. However, I did get some good citations from it, mostly because it's one of the earliest work that explored the arm swing for locomotion. And it sort of balances the idea between what you think is a natural form of locomotion versus what is an unnatural form of locomotion versus what you find to be an efficient form of motion that takes less space or less energy. So sort of like a brief comparison between like running in place, arm swing, and obviously the more conventional, moving the analog sticks to move around. So in my exploration of moving around in VR, the second thing that dawned on me is, so we looked at different ways to move around, and even until this day, is it's not the most interesting research question anymore, I think, in moving around. However, there's also still no very much like a clear solution. What is the definitive way? At this point, I do believe that there's no very definitive way, depending on the context of application in VR. However, one thing I was thinking about at the time too was how do we define, is there a way of locomotion that is accurate? Like it's specifically designed for you to move around and for professional applications where you can have very small corrections. So because things like arm swing and jogging in place, it's not something that would be that you would say is accurate. You do a little bit of overstep sometimes, you know, and so on. Even using the thumbsticks, moving around like, you know, analog sticks is also not the most accurate because you have to map your whole sense of movements to a little stick moving around. So now that we have a spatial movement, we're able to use spatial movement for VR. How do we, is there a possible way to design something which we call to be, we deem to be the most accurate way of moving around? And so we come up with this work as well. It's called pinch move. And just, it's a very simple idea, but the idea is that you're able to move around as accurate as how much you move around in physical space. And now you will see something like this being used for a lot of applications. I believe it was used in a lot of like collaborative sculpting works or collaborative painting works. Now this kind of locomotion is being used a lot already. And one of the interesting parts is actually how you rotate around, how you grab some space and you rotate around. And this actually is a little bit more complicated than you think on how to create such a system. So when you can grab with two hands or you grab with one hand, how do you position yourself to be the most accurate possible at a certain point of time? So we designed a full experiment based on the locomotion of each, the spatial movement of each hand, and how we can perceive it to be the most accurate form of movement. So I think that was quite interesting overall in this sort of my explorations in locomotion in the early days. Now this one takes it a step further, any orbit. In the first two works, arm swing and pinch move, you can sort of imagine in your mind the experience, how it would be like, mostly because it's something that's probably already widely adopted in some applications. This one, however, is not so much the case, and it sort of pushes the boundaries a little bit further. And this one, if you may notice, is published in ETRA. ETRA is actually an eye tracking conference. So what does locomotion have in common with eye tracking? It's something that's a little bit challenging. The idea of this research is actually, are we able to move around virtual space with our eyes, sort of like some certain way, like sort of hands-free, to move around hands-free? And I do see some strong potential applications for this, you know, if your hands to be used for different kinds of applications. So how do we design this? And it's quite challenging, and obviously you need to worry about motion sickness as well. Now it's hard to understand maybe completely from video, but while this actually some kind of like a grappling mechanism based on eye tracking. So the idea is that in the virtual world, there are grappling points, or points of interest, things that you can look and focus on. And once you look and focus on with your gaze, you are able to navigate as in terms of a circular motion around that point using your head gaze. And actually, head direction, head rotation. By combining head rotation with your gaze at the point of interest, you are actually able to move virtually anywhere in physical space without feeling motion sick. And that's the interesting part. It's simply because the world moves around in accordance to how you rotate your head. So you actually don't feel motion sick. And this is some sort of like very interesting research we managed to, yeah, in this video here is actually quite interesting. Sort of depending on where you focus, your head rotates and sort of translates smoothly to the next point. And this can only be done through an algorithm that is designed with your head movement model around a torus. If you imagine you're just locked onto something in VR, like this, for example, on this player, and you move your head around, you can imagine like it's like a sphere model, isn't it? You move around like a sphere, but the only way for you to be able to transition to another object somewhere else smoothly and without creating motion sick is to model the motion as a torus, actually. And that's the only possible way. So in this example here, you can see the movement model changes from toroidal to spherical depending on where you change your focus is going to be. And this allows you to actually look around without using your hands, and also move around without using your hands. And that's sort of a very interesting. So we also explore like sort of AR applications and VR applications, sports spectating, 3D modeling softwares, and so on, you know, gaming, and see what we can do with that. this is another form of hands-free VR input. So in this application, this is a little bit less on the locomotion part, but more so on the interaction part, which is how can we design, or what kind of sensing method we can use to interact in the virtual space, without using our hands. So this work is published in a Springer VR journal, and it's about combining electromyography, which is, I believe right now, is something that's actively being looked at by Meta for interactions in VR. So we use electromyography, muscle sensing, together with gaze detection to be able to create different kinds of hands-free interactions. And actually, during 2018, it's also very hard to find eye tracking HMDs. Today, you find it in PSVR, Quest Pro, and so on and so forth. So last time we had to create some kind of like a Frankenstein headset by just destroying a DK tool, cutting open the lens, fitting in a pair of pupil eye trackers, and sort of exploring different modalities between the use of muscle activation with gaze detection and how we can design and develop different kinds of ways to interact. You saw one of them is also locomotion. How do you move around using these two modalities with very minimal body movement, actually. So looking at these interactions, when I was working on some of these, different kinds of locomotions and interactions in VR space, I came to notice that there's one interesting pattern going on there, is that it borders the line between what you deem to be natural and what you deem to be efficient. There's a generally common knowledge, I suppose, that when you're trying to design interactions in virtual space, you want them to be natural, right? You think about natural, but when you think about it, why is natural so important? Is it the fear that people will take a long time to learn something, or isn't there something that could potentially be better now that we are in a virtual space? Right? How do you define natural? Are we trying to make the virtual space to be the same like real life? Because to me, it's not about being same in real life. It's about trying to make it better than real life now that we have a system that is fully manipulatable and can change our perception of space. So to me, natural is not the important point. The important point is to be efficient in the motion. And I realized that these works that I explore are actually looking into the efficiency of motion. It takes less space. It takes, just thinking about space and time and amount of motion is generally, amount of energy used is actually more efficient. It may not be the most natural, but it's more efficient. And one of the things that I talked about actually during my PhD presentation, PhD defense, was that we should prioritize more on efficiency and less on natural. And one of the ways to explain this is like when you first learn to walk. To us, walking with our two legs, our locomotion right now, we think it's natural. But is it really natural? You are not actually born in this world walking with 2 feet. You're born in this world with your arms, with walking on 4, right? We crawl around at the beginning. You have to learn, and by falling down, how to be able to walk. So then, judging by this logic, is natural really the important point? It's the part about efficiency, to me, that's more important. So we transition to walking with our 2 legs, and this allows us now for our hands to be free to interact with the world. And so it becomes more efficient. We use less limbs. And so if we can use VR or VR technology to create a more efficient motion and change our perception of moving around, interacting with the world, how then can we look at this as sort of like the next evolution of how we interact with space? So it brings about the topic of perception and how it can finally change our behavior. And if something like an unrealistic interaction is proposed, like moving around with your gaze point, or moving around or just interacting with space just by a small muscle twitch, is it bad if it makes the task more efficient? If you just sacrifice a bit of natural, because we are humans, we are very adaptive, we can learn things easily. So to me, it's more about making things more efficient, and that's something that I discuss a lot during my PhD. Now, this is also sort of the turning point of my research, where I realized that I'm more interested in the perception and behavior and learning these aspects of XR, as opposed to developing new display technology or new environmental tracking. Those are of course important, but for me, I'm more interested in the perception and the behavior of how this can affect. So this brings me to some of my more later research that I do in the last couple of years. And also to try to understand what exactly is the metaverse. Metaverse is something that we hear about in the last 1-2 years, obviously thanks to Meta. But it essentially just means AR, VR, MR. This sort of like social future. So the first question is, you try to picture Metaverse as you know of it today. All of you, or I suppose most of you, are researchers that's related to Metaverse. Picture this Metaverse that you know today, and exactly how do you imagine it to be like? What's the first image that comes to mind when you think about the Metaverse? And at least, to most people, and me included, before I thought about this a bit more deeply, it's just, someone in a virtual space, typical looking person, put on a VR headset, grabbing some VR controllers, having some fun, maybe having a meeting online with some friends, socializing using VR chat, so on and so forth. But I think it needs to be more than that. We need to take it to the next step and think about how the different users are able to use a VR headset. So then my thought leads more towards something like this. Like, can we imagine a society? Well, they look a bit terrible thanks to the AI generated images, but it gets the message across, about children using the VR headset, elderly using headsets, being in mixed reality, disabled people using mixed reality. What do they use for? What do they use it for? Is this also going to be for fun? And how is the social environment going to be designed like? So this also leads my thinking a little bit more to not just the perception, but how we can actually help users, how we can understand them, how we can help understand ourselves, and sort of create a better environment overall. So I give it a lot of thought on how XR should be redefined. And to me personally, when I say XR, I don't want to think about just expensive headsets in AR, VR, MR headsets that's just purely about the sensory stimuli like visual, auditory, taste, touch, olfactory, sensory stimuli, but it's about extending reality, isn't it? It's about how you perceive the world. So this would include things like your emotional state, your physiological state, and your cognitive states. And this is basically how I look at XR right now. So at this point on, when I say XR, I don't specifically mean just exploration using nice, expensive VR headsets, but also about different kinds of technology that stimulates your emotional, physical, cognitive, and also different kinds of sensory feedback. So to me, XR is technology that changes our perception of reality beyond just visuals and sounds and so on. And when the perception of reality changes, how does this fundamentally changes as well? How does it change our behavior, our learning, how we interact with others, our social environment? And a very important question for me is what is its social impact? And I think as a new researcher, as a novice researcher, as a new student jumping into master's or PhD, it's important to keep asking yourself, what do you think is the social impact of your research? How do you think it can affect not just you getting a doctor in your name, but how it can change the environment in a very small way, but in a better way. One of the research projects I'm a part of right now in KMD is something called the cybernetic being moonshot. It has nothing to do with the moon. Well, moonshot is actually it's just an English word for aiming far and beyond. So it's nothing to do with the moon. But the title of the project is called Cybernetic Being Moonshot. And the goal is to develop cybernetic avatar technologies that enable people to realize their abilities to the fullest and share their skills and experience. So it's basically about how we can design and develop avatars. Now, when I say avatars, it doesn't necessarily mean VR avatars. It could be physical or virtual. How we can design and develop avatars and use them to augment and to improve and augment our abilities. Maybe also to be able to help us if we are not fully able, but also able to push our limits further. And so this is actually one of the big projects I'm a part of right now in Cybernetic Being Moonshot. And what it is actually projection of how we imagine society in Japan to be like by 2050. So this is an image of the future of 2050, where everyone is being assisted by their avatars. It could be multiple avatars. We could be enjoying different things at the same time. We could be multitasking. We could be shape-shifting. It could be a blend between the metaverse and physical space. It could be anywhere in between. It could be augmented users as well. So this is sort of a big research project right now. Huge collaboration with different universities and companies where we try to develop this cybernetic avatar future. So this is what I mentioned earlier, is basically building a future where people thrive through cybernetic avatars which function as their alternate body. So you can look at it as a form of, it could still be virtual avatars like what you see in VR chat, It could be something more anthropomorphic, more abstract-like, and it could also be in the forms of robots, let's say, a representation of a user. So understand that avatars and agents are sort of different thing. When we say avatars, is actually a representation of a person, as opposed to agents, which is like NPCs or AI-driven agents. Not so much that case, but more about a representation of a physical person. So within this umbrella of moonshot research, what I'm actually proposing and exploring, which is, I believe, something that Aladdin was also requesting me to talk about a little bit, is this idea of the empathic metaverse. So this is something that I'm proposing within the umbrella of moonshot cybernetic being moonshot, which is a virtual platform for emotional sharing towards creating a more pro-social society. Essentially, what it is actually how do we is an exploration on how we can define a new mental model of empathy within the metaverse. Now, most of you guys are from empathy and computing lab, so I suppose you understand what it is about empathy. And when you think about empathy, it's about trying to understand someone, right? Trying to be in someone else's shoes. And the way how we do this in real life is actually quite challenging, because it's not like we can immediately understand how someone feels or stressed out just by looking at them. We as humans try our best to hide our emotions. Like me, for example, I may be quite stressed giving this talk at the moment, but you can't tell because I try to hide it, with my sort of smooth talking. Could be same for anyone. You could walk by someone who is maybe pissed that they got fired from their jobs, but they are walking normally. It's only things like very subtle change in intonation or really subtle body language that may be able to let you know a little bit more about that person's current emotional and cognitive states. And to me, it doesn't have to be this way. Like I said before, the way how I imagine an XR space is to be beyond or better than what physical space can offer. If this is how we perceive and understand others, this is our mental model of empathy, right? In the real space, we can have empathy on someone by looking at how their intonation, or hearing their intonation change, or looking at their body language change. This is how we understand empathy. But how do we do it in a virtual space now that things are fully manipulatable? Which is why I'm talking about a new mental model of empathy. How can we, for example, visually perceive if others are feelings in a way beyond how we can normally do it right now? And one of the ways that I'm proposing is this use of bioresponsive avatars. So the idea is that we are represented by some kind of avatars that understands our emotional and cognitive states. And by looking at someone and trying to understand how someone feels, it becomes much easier within the virtual space, and hopefully can be able to create a pro-social society. So this sketch on the right side, sort of a concept idea of empathic metaverse, where there's sort of physical park where some are in the XR space, some may not be, but in the parallel metaverse space, we can clearly see that this person is not feeling right. Maybe you don't understand what rain may be or what a sad shark may be, and this is what it is about the new mental model of empathy. How can we represent emotional and cognitive states differently within the virtual space? So in this example, more obvious example, one person may be like a happy butterfly, social butterfly, and then the other could be like being sad under the rain. And so hopefully this can trigger some kind of social communication that can help others feel better, and also perhaps also help you understand yourself and also help understand others a little bit better in the future. So this is actually the vision of empathic metaverse. I have some research that I will share later on that falls into the umbrella, not all of it, and also a lot of it are still under review. So I cannot share too much at the moment, but hopefully in the near future, you will hear a little bit more. At least for now, I will actually be discussing this topic, also its challenges and considerations. Obviously, there are things like privacy, and so on and so forth to think about in such a future. Now, I'll be discussing a little bit about this in upcoming in a Kai workshop, actually, next week, I believe. And just jumping a little bit more into what I'm different kinds of research done in KO. So I'm in KO right now as a faculty, and I'm part of this moonshot research. But the way how we work is that in this graduate school, it's divided into different kinds of labs. We call it real projects, but they're essentially sort of labs, groups. I'm part of this lab called the Embodied Media Lab, Embodied Media, which you can have a look at the website. You just Google up Embodied Media. And Embodied Media is a very large lab. very, very large, like maybe near 50 people. And so we have different faculties operating in embodied media, and each faculty is in charge of a research group. So I have a specific research group as well within embodied media, and it's called physionetic interactions, which is a combination of two terms. One is about understanding a person's physiological states, and the other one is about the design of cybernetic avatars. So you can see that the group is driven by my vision of within the moonshot space, but also about, obviously students' interest in what they plan to do in the future. So it's about understanding and leveraging the physiological connection between people and their avatars. And when I talk about people, it could be current societal issues, it could be the children, elderly, disabilities, so on and so forth, diversity. And then understanding others in terms of their cognitive states, their mind, their body movement, how they perceive space, their emotional states, and how we can use this to design and develop avatars that can help them or help us understand them. It could be in the form of humanoids, it could be the form of something more anthropomorphic or abstract, or also embedded into space or into the spatial, spatial avatars or something like this. So this is sort of the general umbrella of what we do in physionetic interactions group. And I also have several students working with me. So this is I update this every half a year based on students who graduate in and out. So this is the current state of the group. Right now, I have one PhD student with 2 researchers working with me, and as well as right now it's mainly 9 master students in my group. There will be more coming in the next few weeks, actually, because the new intake just came in, and as well as some external collaborators, as you can see. Some of them are from ECL as well, and some are from Tokyo University. So this is generally what I do within my group, members in my group, sorry. So, okay, enough about that. I'd like to jump a bit more into some of the main research ongoing. I hope I still have time. Well, I still have a bit of time. So I like to divide my research into cognition, assistance, and augmentation, depending on the different umbrellas of work. And these are the sort of the terms that I've been looking into as I try to understand what XR is and how it can be used to help us. I will try to go through each category. So each of them, I will sort of play a quick video or show some images and discuss about them. And I don't want to take too long for each project because I think I have already been talking like 40 minutes before this. So the first topic is XR for cognition. Specifically, it's about how does XR affect our cognitive state? How does XR affect our memory? And how does XR affect our general behavior? And so, as I said before, when I said XR, I don't just mean about VR, AR, VR space. It's about systems that extend our perception of reality. And I'll talk about different projects along the line. One of the first, so actually some of these works, a lot of them in fact are related to works done in ECL. Some of the co-authors may actually be within the audience, within the participants, so they will actually know a lot about this research as well. One of the earliest works done was in ECL, actually, was Trust in Virtual Agent, exploration of how we could trust virtual agents, and this was published in IEEE VR. So the idea here is about how are we able to actually measure how much we can trust the presence of a virtual agent within a VR system. And to do this, we sort of measure different kinds of physiological signals, most notably heart rate, EEG, as well as GSR, skin conductance. And we design a task within the virtual space by also varying the cognitive load. So this is actually the NBAC task. We vary the cognitive load, and by doing so, we also create a virtual agent within the headset that tells you where a certain object is that you're required to look for. So there's an object that you need to look for within the virtual space, and this agent will try to advise you. Now, whether you trust this agent or not is another matter, and how we measure this is based on a few things. One is your physiological response. I'm just going to play the video again. Your physiological response, your behavioral response, meaning how immediate you are to look towards the direction of where the voice tells you to look at, as well as your sort of perceived trust through questionnaires. And we did find some significance regarding this, especially in some physiological features, as well as the user's behavior. So I think this is actually quite interesting on trying to understand trust towards a virtual agent. Right. Another work that we looked at is total recall. So this is a bit more recent. This was last year at IMWood. There's no video for this, but essentially it's about how we can investigate the effects of measuring autobiographical memory within the VR space. So there will be word triggers within the VR space, and then we measure your response in terms of where you look at, your heart rate, as well as your skin conductance. And so it's basically a task where you look at word stimuli that hopefully can trigger some kind of memory recall, past experience. So when we say autobiographical memory, we actually refer to your past experience. And so we try to understand how memory recall can be sensed and created within the virtual space. And then afterwards, we discuss a lot about how it can be leveraged to create some kind of adaptive environment for the future, and how it's basically one of our explorations on the effects of cognition, user cognition in a VR space. So this is actually quite interesting paper in the realm of VR and memory. One interesting demo that was shown in SIGGRAPH Asia 2021 is Wizard of VR, which looks more towards this adaptive VR space. The idea of how I used the term bioresponsive earlier actually for avatars. So this is actually related to that, is a bioresponsive space around you. So at all times, we measure your physiological states, most notably again, heart rate and EDA, and use this to be able to control key variables within your experience in VR. So in this case, it can change the fog, it can change the different sound effects, it can change the different particle effects. And you find that this is one of the, from research that I'll show from now on, there's a lot about this idea of how a virtual space can adapt and how we can design a space that eventually also let us to understand each other as well as understand yourself a little bit more. So this is essentially actually a biofeedback form of experience. What you see is basically who you are on the inside. And that's the idea of this research, obviously shown in a more interactive demo, sort of like a Harry Potter experience, is what it was called, Wizard of VR. Neural drum is another very interesting research. This was also, it was a demo and also a paper at SIGGRAPH Asia 2020. And the idea here is actually very closely related to brain synchronicity, which I believe a lot of, or maybe some of you are also working on. And it's reflected in the form of a collaborative drumming experience. But the drumming part is actually just in terms of it being interaction. The main point is actually how the entire experience is driven through brain synchronicity between you and the opposing user. So both times we measure your brain signals, and at the same time we compute your brain synchronicity. And so how well you'll get scored in the end and how well you perform in the end actually depends on more so on your synchronicity as opposed to your drumming abilities. And how you perceive the space changes based on how synchronized you are with your partner, actually. So if you are less synchronized, the systems try to let you see through a little bit more and see what your partner is doing. And once we find your motions and your brains to be more synchronized, the experience gets elevated with more particle effects and more visuals to sort of bring the enjoyment factor up, and all based on how well and synchronized you are with the participants. So this was quite a fun experience that we developed in SIGGRAPH. You see that's Kunal over there. Okay, a little bit of works too. This is works done in the current lab in KO. So this is called Frisson Wave. So if you are not familiar with what Frisson is, it's actually aesthetic chills, or more common terms, goosebumps. So this is more about when you are experiencing different kinds of visual sensory stimuli, right? You could be watching a movie, you could be playing a VR game, you could be watching a live performance. You will experience goosebumps, which is a sensation where you, not just your hair is standing, but you're also able to enjoy your content a little bit more. And it's usually triggered with higher enjoyment of the system. So we looked about the question of how we can actually trigger this and share this with others among the audience. So this project is actually called Frisson Waves, which is quite interesting because all participants in this live concert, which is, by the way, being organized specifically for this experiment, is actually a live concert with public users attending, and they have signed consent forms, obviously. Everyone here actually wears two things. One is a physiological sensor, general GSR, EDA, and heart rate sensor on your hands. And the second is actually a thermal feedback device on the back of the neck, which is something that we established to be able to create this goosebump sensation, frisson. And it's actually cold thermal feedback in the back of the neck. So when the system detects that one person is experiencing frisson, it sort of propagates to everyone around them to be able to share. So not just we have the knowledge who experiences frisson, but also who they are sharing with to be able to trigger their own frisson. And so it sort of increases the enjoyment and being able to be more immersed in in the performance. So this is sort of like a system that explores this experience sharing of Frizon. And this was published in IMWOOD as well, I believe. Okay, so this is a little bit about the effects of this, how you can change the sense of reality to affect your cognition. The second topic I'd like to look at is the XR for assistance, how we can actually use this to help other users. So how can XR let us understand and help others, as well as how XR can be used to let us understand and help ourselves. And this is, I suppose, the most in line direction with empathy as well, of course. So I'll just share some works for this sort of domain in my research. One of the main research that I was also requested to share for this talk is Dementia Eyes. So Dementia Eyes was started off also as a demo at SIGGRAPH Asia 2021, and only recently just has been published at CHI in the next week, which we'll be there to present next week. So it's a very interesting work. It's about how we can perceive visually, how we can share the vision of someone who is suffering from dementia. So it involves a lot of co-design process with Mediva. So Mediva is actually the medical consulting company that we were working with for this project. And it's hard to, dementia is actually a very challenging topic because it's not just purely visual based. It's actually, it originates from the brain. It changes how you think and perceive the world, but it also changes how you see the world. And that's something that we are trying to simulate so that we can not just increase empathy, but also allow us to use it to be able to design space better for dementia patients. So to do this, we actually went through a long co-design process with the professional medical practitioners, nurses, doctors, and so on, also caretakers, and trying to tweak the different kinds and trying to understand the different kinds of visual symptoms that will occur for someone who suffers from dementia. I believe there was like six specific symptoms they were looking at, such as poor depth perception, poor light feedback, poor like change in color. I think there's some part in the video that actually shows the different kinds of, yeah, there you go. So vision field defects, how you have overall narrower view, and then there's a sort of decrease in color sensitivity. So the color actually changes a little bit. Pupil dilation makes the light reacts poorly, sort of delayed pupil contraction as well. Presbyopia, which is sort of general blurriness, and so on and so forth. So yeah, the different kinds of symptoms that we co-designed with Mediva, and finally ran a study on also how much we can empathize patients, but also how much we can actually use such a system to be able to help them, right? So now that we put on these headsets, doctors put on the headsets, they are able to see how dementia patients see, and then when they complain about something, we now understand why they're complaining about it, because we sort of understand how they perceive the world visually, at least. I'm not saying that it would be 100% be able to simulate dementia, but at least, in terms of visual speaking, we have a little bit more understanding of what this can, how we can help them as well, and how we can design space to be able to accommodate their sort of movements and how they perceive the world. Another work that is also along the lines of visual impairment simulation is actually, just have a quick look at the time myself. Do I have a time limit for my talk, Aladdin?
Yes, I think we have about 10 minutes or more.
10 minutes? Okay, I'll try my best to go. There's still a few things to share, but maybe I'll just make it roll a little bit faster. So next one is visual impairment simulation glasses. This was published in WIST last year. So it's quite related to the sense of being able to simulate visual impairment. However, here is looking at not using HMDs. Instead, is about trying to develop a specific HMD, a specific eyewear, just to simulate this, to avoid things like motion sickness, or to avoid things like being very bulky on a headset, being tethered somewhere. So it's actually a simple headset based on an LCD and pupil eye trackers. And what it does is actually it tries to simulate two key symptoms. One is the degeneration in the periphery. Another one is on the focus. So it's very closely related to like macular degeneration and glaucoma. That's being, most elderly do suffer from this. And it's actually quite annoying. This is actually quite annoying. Where you look at is basically a patch that you can't quite focus on. And another one is the sort of narrower field of view. So this prototype is designed specifically for this with a very wide field of view compared to VR headsets. And we ran a couple of studies on the main difference in perception of space while wearing the headset versus not wearing it, and how much severely more you're impacted in terms of your vision loss. And this was shown in WIST last year. Nap well there's no videos for this, but essentially what it is the exploration of how VR can be used to improve sleep, which is something is a bit more challenging than you think, because if you think about it, VR is a system that requires you to use your eyes. So when you're sleeping, you're not using your eyes. So how does it actually help? So what this does is actually exploration on reducing sleep onset time, the time required for you to fall asleep. And it combines between the use of a very comfortable VR headset, in this case is the Google Daydream, which is I believe is discontinued, combined with EOG sensing. So EOG sensing is able to detect your eye behavior even with your eyelids closed. So it's as opposed to camera-based eye trackers. So this prototype actually, well, first we looked at how different environments should be designed within the virtual in VR to be able to help you assist to fall asleep. Different people have different ways to help fall asleep, and one of the more common ways shown in research is actually for most people to picture themselves in different environments. Maybe it's in a forest, it could be in a hotel, be by a beach site. So we ran a long survey and determined 4 to 5 main locations, including their own rooms as well. Some people prefer to be within their own rooms when take a nap. And so we designed some of these spaces, and then we also train an EOG model to be able to predict a person's sleep on set time. We also include something called the finger tapping task. So this phone that she's wearing here is using something called the finger tapping task, which is a task that has been shown before to be able to evaluate whether you are getting more drowsy or have fallen asleep. Because as you are awake, you try to do a very, very light tap on the smartphone, which will log the information. And as you slow down and eventually stop tapping, it means you've fallen asleep. And so we use this method to evaluate the decrease in sleep onset time. And we actually did find like some good results regarding the significant drop in the sleep onset time for users within the VR space. Kin Voices was actually a collaboration with AH Lab, Samantha from AH Lab. So this was published at CSCW 2021. So Kin Voices is actually the perception of another person within your room. Now, for maybe a lot of us, we have smart devices, virtual assistants in our home, which like Alexa and Google. I'm mainly using Google at home. However, these are not personalized, and they often come across as not one with emotions. It's basically a computerized generic voice used by Google. Kin Voices actually explored the big question of what if these voices are people that we know? What if it's people that we are accustomed with, in other words, our kins, right? So which is why it's called Kin Voices, and this actually specifically targets sort of like elderly, and how they can find virtual assistants in their homes to be more usable, to be more trustable, now that the voice output has changed to be someone that they know. It could be their child, it could be their partner, and it could be anyone that they decide. So it's just a voice model changed based on data of their kin, and we deployed it into their rooms for an extended period of time. I think it was like 2 weeks, if I'm not mistaken, where there is a technology probe for 2 weeks to explore this effect. And so there were some interesting behavior changes, as well as how much increase in trust they have towards the technology. There's also some increase in creepiness. I believe there were some results in that, because there's also uncanny valley. Uncanny valley is not just limited to visual perception, but also the voice perception as well, and how it can change. So actually it's eeriness, eeriness down here, some change in that. I think that was quite interesting. Gemify was also a work with AH Lab, and this is about developing an interactive wall platform device, which actually installed at ABI, ground floor ABI in the past. And that was during the peak of COVID, and that was actually the main inspiration behind Gemify, where we have a social barrier between us. But even with the social barrier, how are we still able to interact with ways that not just transfer our voice and image like Zoom, but also through the sense of touch and through the sense of collaborative interaction. So this is actually a system. There's a huge interactive wall with LED wall that senses users' motion, so you can interact, but also uses a wearable glove sensing device. It uses shape memory alloy. And the interesting part about shape memory alloy is that it gives squeezing and thermal feedback similar to the sense like someone is touching your hand. And that's actually the goal here. How do we bridge this gap? So what's interesting here is actually you get to interact with this wall. One person can be inside ABI, and another person can be outside ABI to interact with this space. And it was sort of quite interesting process. Fure Kit is something that was published last year at Eurohaptics. Fure may sound strange, but actually in Japanese it means touch. So it's touch kit. And this is a haptic wearable device specifically designed for autistic children, for them to learn a little bit better. So if you've dealt or worked with autistic children before, it can be quite challenging because their attention is always juggling between different locations. They are always feeling awkward interacting with each other. So the idea here is, sorry, the clip's a bit short because we are actually not really able to use the images of the children. We weren't allowed to do that. But so I'm just looping this short video here. Essentially, it's a wearable device that senses your touch and provides audio and haptic feedback via this wearable vest. So we do go through a lot of long design process to be able to decide on one on each shoulder, one on the front abdomen and one on the back. And children's all basically wear these vests and use this for their learning process. And it just overall makes it more fun and engaging. They feel like they should interact, they can interact with each other a little bit better. They sort of more physical interaction with each other and sort of bridge this social barrier between them. And which is something that's actually very useful for an autistic children to learn a little bit more about social space. So this project was called Fure Kit. And this is also an example of things which I feel have very strong social impact. One of the more recent ones is Transcendental Avatar. So this is actually along the lines of the empathic metaverse vision. This work the idea is about exploring how we can use an abstract form of avatar to represent your cognitive self. And also, of course, this is using physiological feedback. The abstraction of the avatar, including the particle effects, the environment, the color, everything is driven by your physiological states. And so we use this for you to create a self-perception of yourself within this virtual space. And so it helps a lot in terms of the biofeedback. It's a biofeedback system, basically, which is something that people actually practice medically, but instead in a virtual scenario where you see yourself as an abstract form over a period of time and how this can help you to regulate stress. So in our previous work in this SIGGRAPH Asia, we're actually looking at this stress regulation for avatar feedback. And right now, actually, in our current step, we're looking at this as an assistive tool. How, again, we can use this for autistic children, maybe, or ADHD patients, what kind of avatar representation can be for them, and how it can be used for them to assist their everyday life, or maybe help them regulate their emotions and cognitive states in the future. And okay, so I hope I still have 1 minute, but let me just go through this XR for augmentation side a little bit more. So XR for augmentation is an exploration for me to understand how we can use XR technology to perform beyond our regular abilities and how we can use it to create new form of perceiving reality. Essentially, it's just an excuse for me to be able to explore more crazy stuff, to be honest. But also, of course, it's about understanding the next step. Now that we find some ways to understanding users, how can we push it to the future? How do you imagine the future society? And how we can use this technology to help us a little bit more and our abilities. So some of the research in this category, the first one is OmniView. This was published in AH in 2020. So OmniView is about actually giving every user 360 vision. So you get 360 vision. There has been some work on giving you 360 vision, which is essentially, oops, that's the next one. Essentially, an equirectangular view. So if you're familiar, by looking at equirectangular view, you actually get to see everywhere 360 all around you. However, the issue with this is that obviously there's going to be very heavy distortion. Human eyes are not built for this. So how we do this is actually depending on where you're looking at within the equirectangular view, we change the distortion so that your gaze point becomes more clear at where you're looking at. So this gives you 360 view, where also clear depending on where you're looking at. It's sort of like foveated rendering, if you're familiar with the term, but instead of blurring, it sort of changes the distortion in 360 view. So we explore different modalities. It could be based on gaze point. It could be based on when someone is talking to you using face tracking. It's also using the controllers. Anyway, I think if I'm not mistaken, we found the gaze point part to be the most effective in terms of augmenting users with 360 vision. And then this brings us to the next question. So now we sort of imagine that everyone has 360 vision. Right? Picture a future where everybody has 360 vision. Now, in this future, where everyone can see everywhere around them, how do you imagine them to be able to interact with each other? Or in other words, how do you imagine face-to-face interaction to be like? Because you don't need to be face-to-face anymore, right? You can be back-to-back, you can be back-to-side, and you can still see each other. So this exploration is actually even further, imagining this future and how we can treat, how does interactions needs to be adapted for 360 vision. And so this becomes two-way. So not only are you able to perceive 360 within, but is also being perceived from others, your 360. So if you are looking at behind, if you're looking behind you, we can see that you're looking behind you via an external display behind you. And so there are 3 displays formed around the headset. And so we use this to do some kind of like social study in terms of also like facing formation, how different users are facing each other and how this can affect the quality of communication, which I think is quite an interesting research question. The more recent one is something called Human Copter. This was published in ICAT last year. This work is about trying to see actually if there's a better way to provide the full body movement across all axes. Now, if you think about technologies that provide you ability to move the body, it's actually quite limited, the amount of technologies. And not only that, it cannot really provide you the sensation of all axes. Now I'm talking about a system that can give you the sensation of moving forward, back, left, right, also sensation of up and down, and also sensation of turning left and right. And right now, actually, one of the devices that can do that is a drone. So imagine having a drone being able to guide a user. So that is actually Human Copter. It is a wearable head drone. If you guys have read Doraemon, he has a little thingy on the head. It's basically like that, except 20 years behind, 30 years, 50 years behind. But essentially what it is a system that's able to guide a user across all axes of movement. And actually, the ultimate goal is be able to create full upper body movement without the external drone load. Ideally, we want it to float above the head. It's just that there's a lot of safety issues at the moment, and also flying drones it's not easy in Japan. You need licenses. So for now, it's tethered to a helmet. And we do an investigation on how this system creates a different perception of moving in all directions and how well it can guide the user. Obviously, using drones comes with limitations, but at least for now, it's investigations of the technology in terms of providing a sense of movement for the user and how eventually we like to explore its assistive function as well, like upper body rehabilitation, maybe, for example. Okay, so that's actually the main 3 pillars. I also still have actually other works, but I just quickly mention them. So these works do not fall into my main pillar of research, but nevertheless are still works that I've worked with a lot of talented researchers. First one is Maze Run VR. So this was in KAI 2020. It's actually also along the lines of locomotion, but how we can create some kind of like in the wild open source platform that every researchers can use to evaluate different kinds of locomotion. So we create a system with different locomotions and create a maze-like environments with a specific task to move around in, and hopefully others can build upon. And the other few more works is actually the collaboration with Google back in ECL. And the first one is evaluation of hand proprioception, which is basically the sense of your hand placement and finger placement, and how we are able to actually understand the locations of each key joints on the hands and how it can potentially be used for interactions while being eyes free. And so this is a sort of an evaluation for that. Third one is called Writing, which is actually also it's using the Google Soli sensor, the radar sensor, and how we can design custom radar reflectors for creating a tangible tabletop experience. So this is also work with a Google collaboration a couple of years back at ECL. So in summary, I'm sorry for taking a little bit of extra time. In summary, XR to me is more than what we know of it today. Things like new trackings and new sensing modalities are always important, and I won't argue with that. However, to me, it's more about how it affects you and also the people around you, and what are the social impacts of the research. So that's something that I'm more keen in understanding. So finally, huge thanks to all these amazing people who did all this hard work, all this research. Of course, none of this is done by me alone. All of them is from different collaborations with different bodies, different parties. So a huge thanks to all of you. And if you want to reach out to me, you can access to my website for more information. All these videos and publications are available on my website. I update it frequently. You can just scan a QR code if you find that easy. And always feel free to contact me via email. I'm also on ECL, Slack, and what's the new platform, Discord. So you can also just message me there actually, if you just want to chat or you want to talk about research. So that's all from me. Thank you so much.
Amazing. Thank you so much, Pai. It was lots of work and inspiring ideas. So now we'll have the time for questions. If anyone has a question, please feel free to ask. I'll start us with one question from me, if that's okay.
Sure, go ahead.
I wanted to know about the empathic agent and why do you think having agents will help us understand about each other and then understand about ourselves? Why the existence of avatar will help?
Thanks, Aladdin. So just to be clear for the questions, I also want to differentiate the understanding between avatars and agents. I think that's something I just very briefly mentioned just now. So to me, or to most of the research that you find, agents are something that's being controlled externally. It could be an AI driven, or it could be, you know, like an NPC in a game. Basically, it's a separate form factor that exists, regardless of how it looks like. Whereas avatar is a representation of an actual person, a person that exists in the physical life, whether they choose to be, for it to be either humanoid form or to be an animal, so on and so forth. So to me, this avatar representation is something that is interesting, and how it can be used to bridge the ability for us to understand each other a little bit better than how we can do so in real life. As we all may also know, among the different kinds of sensory feedback of people, vision is the most dominant. So which is why when we say, you know, AR and VR, or even though these systems are basically a combination of different sensory feedback, audio, visual, but the first thing we think about is the visual feedback, that how we see in space. So in this case, also, how do we then leverage the way how we perceive reality to be able to increase this connection? And the way how I see it is that if we are able to directly change a person's representation, like imagine if someone is able to morph into a shape that they feel reflects their emotional state, or reflects their cognitive state a little bit more better, or perhaps they can, you know, they can disappear or change something instead of just facial expressions. You can't really do that in physical life. So that's something, or at least not until in 100 years or so maybe. So how do we do this? How can we explore this in a way that's not deemed feasible in the physical world? And that's how I see how the metaverse can be leveraged. And so I wish to take this to the next step, and understanding this, maybe a taxonomy or a design language of how we can design ways, not just avatar representation, but could also be the environmental representation, interaction representation, because everything is, you know, everything is in the palm of your hands for the metaverse. And I believe that with this freedom of design is a sort of a perfect platform to explore this.
That's great. So to make the invisible emotions, make them visible using avatar or other representation virtual environment.
Yeah.
Thank you. Any question from someone else? Or
hi, Jan. I have questions.
Sure.
So yeah, so regarding the physiological signal recording, especially EEG, I think it seems that your participants was wearing EEG cap, and also the HMD as well. And also she's like rotate her head really freely. So my question is, how did you control the noises from the movement? So
Yeah.
do you have,
Thank you for the question. So I believe this is probably one of the most common questions. Whenever you see EEG with VR, I ask the same questions, and I am being asked the same question. So to put it simply, there is no easy way to solve this. It will be a problem for now and also the foreseeable future, and it was also a problem for us. There's no denying that. What you're mentioning is basically motion artifact, among other things. Also, like things like the pressure being different because of the headset, right? It presses on different points, so perhaps there's some deformation on the headset. So we do try our best still to minimize motion however we can. If you see some studies, like for example, the total recall is something that's seated and with minimum motion. However, there are also works like the trust one, which requires motion. And so there's not too much that we can do except for ensuring that you do proper pre-processing. So I would advise a few things. Obviously, the first one is you do proper pre-processing. You start off with manually checking each data. You try out different kinds of motion artifact removal algorithms and see if that works. But before that, you want to do proper baselining. So for all physiological sensing, you always do baselining. And one of the very important baselining is to also record signals of motion. So at least you got data for the motion, signals with motion, and then you can always use that for reference. And hopefully be able to helps you to filter out the motion artifact. And lastly, EEG is something that you should not rely 100% upon. If you're going to use EEG, you must always, or at least the way how I see it, you want to always combine it with different kinds of sensing modalities. So it's something that will assist in combination with different modalities, but to rely on it alone will be very, very challenging. So this is at least some of the things that we do, and also some of the things that I advise you to try out if you're going to explore EEG in VR.
Yeah, so do you mean you recorded additional recording session for like standardized movement? Like
yes, yeah. So that's something that I recommend. So if your task requires you to move around your head a lot, requires you, at least before you start the task, ask the user to do some kind of similar movement, and you know, while being in this empty white room, for example, do a similar movement and do a recording, sort of like a baseline motion artifact data, among other things. So that, and also pre-processing, and also combined with different kinds of sensors. At least this helps minimize, not remove, but minimize the artifacts and issues you may have.
Yeah, I see. Thank you for your advice.
Sure.
Great question. Anyone else? I have a question about the drum project.
Neural drum.
Yes, you said the partner will be more visible when it's less sync. I was wondering about why the choice is
right. Okay.
This way and not the other way around.
Yeah, I'm just trying to find for the neural drum. Which one is it? This one? Trust, total recall, neural drum. There you go. Yeah. So the reason we do this is because when we look into hyperscanning research in the past, we find that synchronized movements is something that can improve synchronicity. So synchronized movements can be achieved when you are obviously able to see what your partner is doing and you can move in the same way. So when we find that you have low synchronicity, we let the camera see through a little bit more, and this allows you to see your partner's movements a bit more clearly. And when you can see their movements a bit more clearly, you try to synchronize your movements, which in return increase synchronicity, which in return changes the visuals. So it's actually sort of like a closed feedback loop system. And the idea is that by doing so, we can keep improving on the synchronicity to the final point where the final experience is just, you know, the best for both of you. Admittedly, it doesn't work for everyone. It depends, because there's also different skill level. Also, if you hate your partner, regardless of how synchronized you are, you're going to hate the partner, and that is not going to work. So there are obviously different variables, but in terms of the explorations of synchronicity, that's something that we were looking at.
I see. Thank you. Rio, you have a question?
Rio-san.
Sorry, I don't think I can hear you. I don't know if...
Can you hear me?
Yes, now.
Cool. Sweet. Thanks for your presentation. It's super cool to see all the projects through the years you've done. I'm actually very curious about your empathic metaverse concept, where you mentioned that you're more like focusing on the more like emotion cues between the people in the same metaverse environment. And then I'm just curious, would you consider those like a physical interaction? Let's say like in Japan a few years ago, there were some sort of like cushion that is having a sort of like cat fur sort of thing.
Yes, I know that. Yeah.
I forgot it's kind of robot that with the
I forgot the name, but I'm very familiar with that.
Pillow. the pillows,
Yeah.
the cat
Pillow
pillow.
with a tail, isn't it? Yeah, that's cute.
Yeah, that one. Or like in Japan, I believe digital twin is more buzzword rather than the metaverse, from my understanding. So I'm just wondering, or like I'm more curious, what are you interested in looking into those like sort of like shared physical experience by like
Right,
animals or like objects?
Yeah. Got it.
More like those like different cues.
Yeah, thank you. I suppose what you're actually trying to say is perhaps tactile feedback is one of the other things to potentially explore within sort of metaverse space. And you also brought forward the terms like digital twin, which yes is also a buzzword that's being thrown around a lot. Actually, when you say digital twin, I'm not sure what exactly as well does it mean. It also means like a avatar in the virtual space. And in that regard, it's not
Yeah, no, sorry. I just brought up the digital twin because they're often the case that we like augment the actual space rather than the full digital space, rather than the, I don't know, some metaverse concept.
Right. So anyway, I suppose you're bringing the point of more exploration with the physical, or maybe bridging the gap between physical and virtual. When it comes to my interests, yes, I think that's interesting, and there's a form of exploration. However, it's also when I come up with this concept of empathic metaverse, is also more along the lines of no overlap with the other researchers within the Moonshot umbrella. So in Moonshot research, there are also others more focused on the tactile side, more focused on the robotic side. So I try to propose a vision where it's can run in parallel with some of the other research. So there are actually other researchers who are exploring what you are talking about. So I try to find something that can also complement each other's research. But in terms of my personal interest, yes, I think that's actually quite interesting on how different kinds of tactile feedback can influence sort of, maybe it's also like empathy and perception. I know that there's one or also several students in our lab working on this idea of haptic empathy, how different kinds of haptic patterns can be related to different forms of emotional feedback. So they're doing this mapping. My mapping is more on the perception within the metaverse space overall. I suppose at some point it will be combined to create this whole system in the future.
Thanks. Yeah, I know KMD is very famous for those different kind of tactile
Yes, it is.
projects. So yeah, that will be very interesting. Thanks.
Thank you.
Thank you, Rio. I wanted to ask a sort of a bigger question. You said about the vision and how you always encourage people to ask what is the social impact. What's the process you use to define your vision or find directions? I know sometimes we look back and say, these projects are part of this umbrella and so on, but looking forward or applying for grants or collaboration with industry, as you mentioned, I guess that second question, how do you find these collaboration with industry?
Okay, maybe I'll answer the second question first, because the first one I need some time to think about the answer.
Okay.
So I'll do the second one first. So how to initiate collaborations? A lot of this is actually really about stepping out of the comfort zone. Is a balance of several things, luck included, to be honest. So it's about how you can connect different things. In the past, when I got into these projects, the first time was during like my master's and my early PhD. It's a bit less on me finding myself and more so than connections already established by supervisors. Perhaps they know a guy who knows a guy, and then usually as students, the task gets passed down to you to be implementing a system, to be building a system, and so you naturally become a part of the collaboration. And as you do well, you sort of level up and perhaps directly connect with the company, and then they can also link you to different kinds of potential collaborators afterwards. So there is sort of a way to do that. And the way how you find collaborations in industry is almost not so different with trying to do like, job hunting. In the end, it depends a lot with the connections that you establish with people, the people that you meet in conferences, because they also come to conferences. And one good thing about being in embodied media in my lab is that it's been around for a while already, at least since the very beginning. Maybe I think since the beginning of the graduate school, the lab has been around. It used to be headed by a different professor, and then it sort of passed down, if I'm not mistaken. Could be wrong, but I think that's how it was. And the lab's roots are already very strong, and they've already collaborated with a lot of departments and a lot of companies. And so when I came in, they already told me like, okay, these are the different bodies that we work with. Perhaps there's one that you find interesting, that one you can build on. And so at that point, Medieval was like the starting point, or the sort of very started collaborating with us. And I thought, that topic sounds nice. I will be part of this project, and I'll work with the students to sort of fulfill the outcome. And so it's sort of like it all starts from I know a person who knows person who knows person, and that it's there's no shortcut to that either. It's just trying to just jump in, try to make it work. And I suppose this leads to also the whole social impact direction, because I do think that by collaborating with companies, you do boost the overall social impact. So which comes first is hard to say. The important point is that you need to be flexible with the approach of your research. You may need to change the direction a little bit depending on what the company or your stakeholders will require you to achieve. You may need to change a little bit depending on what comes out to be feasible, and so on and so forth. So there's a lot of variables that comes into play when you talk about these things. And in the regards of like social impact, when you work with companies, this means that they have, some of them, their goals could be publishing papers like mine or like a lot of us. It could be trying to submit patents, get patents to be out there, or it could be getting a service out, maybe publish an app online or getting a physical product out there. And this means appealing to the general consumers. And then by doing so, you do have a slightly stronger social impact, also gives you a bigger platform to collect more data and so on and so forth. But this is obviously a very challenging task. It depends on what is required by your collaborators at that point of time. I'm not sure if this led to answering the first question, or was the first question again? I hope it
Yes.
did. Yeah, okay.
Yes, thank you so much. Yeah, I know
Sure.
this is sort of like it's not always clear or a direct path or a prescribed path, but it's interesting to see how researchers they conceptualize their vision and how they. Well done on what you achieved so far. Any other questions from anyone in the audience?
I had a question.
Yes.
Thanks so much for the presentation, Pai. I just had a question about the drone. Can you go to the slide, the drone on it, the head-mounted?
Move the, oops, what did I just press? Get back there. So I have my Zoom window blocking everything. Okay.
That's okay, that's fine.
There you go, human copter.
Yeah, so I wasn't sure what type of user evaluation or how you'd evaluate this in the future going forward. It seems like a really interesting concept, but
okay.
Yeah, a bit more detail about your future plans for that.
Yeah, sure. Thanks, Mark. So actually, maybe I'll start with the very initial vision, but we didn't actually manage to achieve that vision. So we just brought on to a simpler version and it ended up with this. The first vision was actually to design a system that can provide full upper body movement, full upper body kinesthetic feedback. So basically a system that can at least give you a sense of moving your upper body, which means this like from waist upwards, arms and all this, without the additional perceived load on the user. Because when you think about systems that can move the upper body, it's usually more heavy-duty robotic systems or like exoskeletons, or like the lightest being, I suppose, artificial muscles, but would also require giant pumps and so on. And I was interested to see how drones can be used for this. And in other words, actually, the vision of it is like, like a marionette doll with strings attached. I was imagining something like this, but with strings attached to a drone above you. So essentially, this drone above you is like, it was part of the whole avatar vision as well, actually. And how this drone can be used for upper body, to give you upper body movement, how it can help for maybe remote collaboration. Let's say there's somebody else taking direct control of your drone to move you around, so you can move your full body. So, it's not just a drone, but there are some motors linked up there that's connected to different key joints of your body, so you can move the upper body and pick up stuff, open doors, so on and so forth. That was the vision. However, there was a lot of technical difficulties for that. Most notably, that flying drones is difficult in Japan. So I only could do it indoors, but there was not big enough space to do that. And secondly, it's the safety. I could not convince anyone that it's safe enough to fly a drone just above the head without it having the possibility of crashing. And so you need some kind of safety device. So then this brought down the vision to a little bit more. And so we just tried to explore what kind of sensation a drone can provide to the user. And this just sort of happened while testing the drone. So what we did was actually just flying the drone up. What I did was just grab the drone legs, and while someone else was controlling the drones, I could find myself going forward, going back, even feeling the sensation of going down, going to, rising, lowering my body, turning left, turning right. And I find this to be quite interesting because I don't think there's any other sort of proper system that can establish all this sense of direction. And so this human copter, at least, is the initial investigation on how how drones can be turned into a wearable device to let the users to provide kinesthetic feedback to the users across all directions. And going forward, I still want to look into the idea of how we can attach some ways to make it into a full upper body system, and also eventually how it can use for assistance. But there's a lot of challenges to be overcome. If you can see, I mean, the typical challenges of drones still apply. First of all is the battery life, which can potentially be overcome by a tethered device, but then if it's tethered, then it sort of defeats the purpose. And then there's the sound, it's very noisy, and so you can't really do other things besides besides having the thing moving around you. And also it's very windy. It sort of blows air directly towards you, as though it just feels like something is taking off above you. So there are a lot of challenges, but at least in terms of the sensation of movement, I think there's actually quite a strong research area there potentially. So sort of the ideas to go forward afterwards is overcome some of these challenges and hopefully upper body movement.
That's
Thank
great.
you.
Thanks so much. That was really great. Thank you.
Thank you.
But I guess the evaluation in terms of what Mark has to.
Oh, right. Sorry. Yeah. The evaluation here was about so we place objects around the physical space at different heights and at different positions within this square, and we try to navigate the user and see if they know exactly which item they're supposed to be interacting with, and then we evaluate how close they are, how far they are from the device. So that was sort of the evaluation in terms of the navigation and direction. Sorry, I missed that part, but yeah.
Thank you. No, that's great. Yeah, it's good to see how original vision, how it changed with the current implementation. I think that brings us to concluding the session. So thank you so much for taking the time to talk to us about your research. Thank you for everyone who came here and asked questions and listened. I hope you found this information useful. Thank you again, Pai. I hope we get to see you again in New Zealand or in Japan or future collaboration in the future.
Definitely. Thank you so much for inviting me, and looking forward to any potential future collaborations as well.
Sounds good. Thank you.
All right. Thank you.